Okay, in today's lesson, we have 4 objectives. We will review the formula for a linear equation. We will learn what each variable means in the linear equation. We will learn how to solve for missing variables in the equation. And we will learn how to graph linear equations. Okay? The TEKS aligned with our class, with our grade, is 111.27, grade 7. It states, expressions, equations, and relationships. The student applies mathematical process standards to represent linear relationships using multiple representations. The student is expected to represent linear relationships using verbal descriptions, tables, graphs, and equations that simplify to the form of y equals mx plus b. Okay, to relate to last year's learnings in 6th grade, TEKS 111.26, grade 6 for this objective states, expressions, equations, and relationships. The student applies mathematical process standards to use equations. So if we look over here, we're starting at our top left where it says y equals mx plus b. This is our generic form for a linear equation. But before we start using this equation, we got to figure out what each letter means. Each letter in this equation is a variable. What is a variable? A variable is a placeholder for a number that we do not know yet. So each of these letters, y, m, x, and b, they are variables. They're placeholders for numbers we don't know yet. Once we know a specific number for that letter, we can substitute it in for that number. For example, if we're looking at our x and our x and our y can come from 2 different things. A coordinate, or a point, which is always written x, y, or it can come from a table, which is written like this. Just like that. So, for instance, our x in the coordinate will always be our left number, and our y will always be our right number. So if we're given the coordinate 1, 2, our 1 is our x, and our 2 is our y. So if we substitute our 1 right here for x, and our 2 right here for y, the equation will look like 2 equals m 1 plus b. M times 1, since these are multiplied together. Parentheses also represents multiplication. Now, what exactly does our m and our b mean? We're going to come over here for that. Okay? Our m is our slope of the line. Okay? Our b is our y-intercept. Now, what exactly does slope mean? Slope means our steepness of our line. Remember, our linear equation, linear lines, they're always going to be straight. They're just going to be at an angle. That's what our slope is. It's that angle. It's that steepness of the line. Our slope, for example, if this was our line, that's a pretty steep line. Our slope would be steep. Right here, if that was our line, it's not as steep as this line. Our slope is 2 different numbers in this case. Our b is our y-intercept. So if we have a graph, our b is where our line would cross the y-axis like so with a specific line. Now remember, our y-intercept is whenever x equals 0. So right here, our x would be 0, and let's say we go up 1, 2, 3. Our y-intercept would be 3 because x is 0 and that's where it crosses. That's our point. So our b, our y-intercept, will always be in our linear equation where our line crosses the y-axis. So if we don't have a b, if it's just y equals mx, that means our b is 0. That means that in our equation, or if we're graphing our line, it'll pass through our origin, which is 0, 0. Our b can also be negative. So if we have our another line right here, and we go 1, 2, 3, that is a negative 3 because we went down on the y-axis, but we still have our x equals 0. So it'll be 0, negative 3. That'll be our b, right? So if we have a line, okay, and we have our m is 2, and our b is 1, how would we plot this, for example? If we have our graph like this, remember our b is where x equals 0. So we can write this as 0, 1. And if we plot that, we don't move left or right because we're at 0, and we go up 1. That is our b. Okay? And remember, a whole number as a fraction is the same as putting it over 1, and our slope is rise over run. So we go up 2 over 1. And that's going to be our line for our linear equation for this. And our equation would be y equals 2x plus 1, with this being our m and this being our b. Okay? So let's practice it with this word problem at the top right. A salesperson receives a base salary of $15,000 and a commission of $100 per every sale he or she makes. Write the linear equation for the salesperson. How much money would he or she receive for 5 sales? Now let's look at our question up here. Okay? We're given a base of $15,000 and $100 per. Remember, per means multiply. In our equation, y equals mx plus b, the only two variables that are multiplying are right here, m and our x. So very quickly, I can see that my m is going to be our slope, because that's what we're going to multiply x by. Our m would have to be 100. Okay? And this means, with process of elimination, with this number being last, our b is 15,000. And here's why. If we're given a table, just like this, x, y, or if we create our own table, for instance, he receives a base salary of $15,000 no matter what. So if he sells 0 items, he will still make $15,000. And remember over here, whenever x is 0 and y has a number, that's our y-intercept or our b, which is why we have 15,000 right here. So for this answer, for this question, write the linear equation for the salesperson. It would be y equals 100x plus 15,000. Okay? Now remember, our y is our total amount he sells, and our x is how many sales he makes. So how much money would he or she receive for 5 sales? So if our x is our sales and our y is our total, if we have 5 sales, we have to plug that in for x to find our total. So we have y equals 100 times 5 plus 15,000. And that's how we solve for y right here. We have to multiply, doing order of operations first, and then add it to 15,000. So 100 times 5 is 500 plus 1,500. 15,000, I'm sorry, not 1,500. And now you add those together, so our y equals $15,500. That's how much he or she would make if she sold 5 items. Okay? So now let's look right here. Okay? If I have a graph like this, and I have 1, 2, 3. Remember, this is our y-intercept because we're crossing right here. So this is going to be our point 0.03. Now, what if I have a line that is like this? And all of these, we've seen our lines go rising from left to right. But this one, it's going down from left to right. So what does that mean? Remember, our equation for this is y equals mx plus b. If we have a line that's going downward from left to right, all that is saying is y equals negative mx plus b. Meaning we have a negative slope. We're going downhill. We have a negative steepness of our line. So anytime we have a line like this, or like this, or like that, either way, it's always going to be in the form of y equals negative mx plus b. Okay? So, if we go over here, we're going to plot 2 of these. If I have m equals 2 and b equals negative 3, we have a negative 3 right here because that's our y-intercept. And remember, it's rise over run, so it's really 2 over 1. Then we rise up 2 and we go over 1. That's going to be our linear line for this one. Okay? Now we're going to switch it up over here. If my m is a negative 1 and our b is a positive 2, it's still this time it's a fall over run since it's a negative, right? But it's still a 1 over 1. We're going down 1 and over 1. So if we have b equals 2 and we have a negative slope, we have to go down 1 over 1. Just like that. And that's going to be our equation for that line. Okay? Now we're going to practice this together. We're going to go over some more examples, and hopefully by the end of class, you have mastered our linear equation of y equals mx plus b or y equals negative mx plus b. Thank you.